Okay, we shall begin. Okay, so we are kind of going through Python, talking about some of the different structures, data structures that exist in Python, and today we will talk about tuples. Okay, so tuples are very much like lists, except they are immutable. Okay. So we think about a list in Python, and that's a data structure that can contain different values, multiple values in different data types. And as far as a list goes, the order of the values is important, right? So in our previous lecture, on Monday's lecture, we talked about dictionaries. We introduced lists last week, and we said, they're iterable structures. You can either indexed by position. You can get these different values. You can store different things in there. And then on Monday, we talked about dictionaries. Dictionaries don't have an ordering, but you reference the items in a dictionary by their key. Okay. And tuples are a lot like lists in that they are ordered. So you grab the values by their position. Okay. But the key difference here is that tuples are immutable. Okay, so once you create a tuple, it is set. You cannot append to a tuple. You cannot replace a value in a tuple. You can't say like, okay, I want to, with a list, you could assign back to, index position 0, and you can replace the value in the 0 position. With a tuple, you're not allowed to do that, okay? And so you might wonder, like, tuples seem more restrictive than a list. Like, why do we even need, why can't we just use lists for everything? Why do we need to have a tuple as a thing that's separate from a list? Okay, and it turns out that this property of being immutable, okay, meaning that once you create it, it can't be modified, is actually very useful in certain scenarios. Okay, so the fact that once you create something and it can't be changed is advantageous. Okay, so it's kind of like asking, why would you ever write something in pen if you could always write in pencil? Okay, because with pencil, if you make a mistake, you can go back and change it and things like that, right? Whereas with a pen, it's more restrictive, right? But we have different use cases, right? Sometimes the property that once you've written it down in pen and it can't be changed is an advantage, okay? In that, that somebody didn't mess around with it later on and type of things like that. So just like in real life, we have pens and pencils that, serve similar functions, but in some cases, you want to make sure you do it in pen and not pencil. Similarly, in Python, sometimes you want to use a tuple and not a list, okay? So the key difference here is that tuples are different from lists. You can't append to a tuple or modify values in a tuple. The way you create a tuple is you'll use curved braces, okay? So just parentheses is how you kind of create a tuple. A list, you use square brackets, okay? Square braces or square brackets. With tuples, you used curved or parentheses, okay? Or if you just have values separated by a comma, then Python will automatically interpret this and say, oh, okay, you're making a tuple here, okay? So here, if I just take these values, different kinds of values, 0, apple, 2, cat, dog, 5, 6, okay? And then this is going to create a tuple here. So I can ask, hey, what is T, this tuple that I just created? And when you kind of ask for it, it comes back with the parentheses indicating that it is indeed a tuple, okay? And then I created this tuple kind of so that index 1 starts with an A because that's the first letter of the alphabet. Index 3 starts with a C. Index 4 starts with a D, so on and so forth, okay? You can create the same tuple with parentheses, and you get the same result, okay? Right. You can also create a tuple with one value with having a trailing comma, okay? So here is this tuple is created, and it looks like this, okay? So this This is a tuple of length 1, okay? A tuple of length 1. So if you say, hey, what is the type on this? It will come back and it'll say, hey, yeah, that's a tuple. Indeed, that's a tuple. And then what is the length? It is a length 1 tuple, okay? But if you just do parentheses and you don't put a comma in there, okay, this is just going to be the character string A, okay? So what is the type on this? This is just the string, character string A. So this doesn't create a tuple. If you want a length 1 tuple, you have to put in a comma with nothing after it, okay? So this is a tuple. This is just the character string with the letter A in it. Okay, you can also create an empty tuple by calling tuple like this, all right? And so this is our constructor function. So just like you would call list or dictionary, and you can put things and it'll turn it into a list, or put things inside dict to make a dictionary. You can create an empty tuple with this, and you can also put things into the tuple to make it into a tuple. So you can take anything so this is what an empty tuple looks like, just parentheses with nothing inside, as one might expect. And then you can take any kind of other iterable and convert those into tuples by throwing them into a tuple. So strings themselves are iterables where each of the elements, each character is considered an element of the iterable. So if I take the string hello, H-E-L-L-O, and I make a tuple out of it, what I'm going to get is a tuple with characters H, E, L, L, and O as separate elements in the tuple, okay? So it separates that out, okay? That's different from what? Taking the string hello and throwing that, making it a tuple here, right? So these two things are different, right? This is going to be a length 5 tuple, and this is a length 1 tuple. Okay? What happens when you throw list, hello, into list here? Okay? So throwing hello into list converts it into a length 5 list, okay? Or each of the elements here, okay? Versus here, this is the creation of a list with one element with hello, okay? So I think sometimes this surprises students, is that when you take a string and you throw it into list, you often think, sometimes students will think, or people who are new to Python feel like, if I do list with this, we should get this, okay? But you have to kind of, again, imagine a string itself as just another kind of iterable, okay? And where each character is an element. So if you want this, a length 1 thing where the element is hello itself, then you use kind of the square bracket or the tuple notation here. Whereas if you throw it into the function list or the function tuple, it's going to separate it out into the individual elements there. Okay. All right. Tuple range 5. What are we going to get there? A tuple with 0, 1, 2, 3, 4. Right. Okay. So the range object creates basically this range thing where you start off at, generally you start off at 0 and you go up to create something of the length that you've specified there. Okay. Here I'm taking a list with values 1, 4, 7, and I'm throwing them into tuple, and so that's just going to basically convert the list into a tuple. So basically, instead of list 147, I get tuple 147. Okay. All right. Indexing and slicing rules that work for lists work for tuples the same. Okay. So this, I think, is no surprise. So when I say, hey, if this is my tuple and I say, hey, give me the index 1 position, the value at position index 1, what do we get? We're going to get back the character string apple. Okay. And if I say, hey, slice from 2 to 5, what are we going to get? 2 cat dog. Okay. And we get basically a tuple subset here. Okay. Let me see. Let me go ahead and give you your first view quiz answer for today. Is Wednesday. Okay. B as in bear is your first The answer B. All right, so again, the key difference between a tuple and a list is that the tuple cannot be modified. So here I'm creating two, basically the same things, except one is a tuple with a parentheses, curved brace to create it. And then here I've got L, and that's going to be basically the equivalent list with a square brace. So here with a list, I can say, hey, replace the index 0 position with the value 100, and I could print out the list, and indeed, the value index 0, the value at index 0 is no longer, has now changed to 100, okay? Whereas if you try to do the same kind of thing with the tuple, you get an error, okay? It says tuple object does not support item assignment, okay? You get a type error. It says this is the wrong kind of data type that you're working with. To try to do this, that's just not going to work with a tuple. Okay. Right. Again, it's kind of like if you tell someone, "Hey, I want you to write in pen," and then you say, "Hey, erase the first word that you wrote." They're going to say, "I can't. I wrote it with pen. You told me to write it with a pen." Okay. Okay. So similarly, the list has methods that are going to modify the list. You have things like append and pop and I don't know, any of these methods that exist as far as modifying the list, okay? They just don't work with a tuple, okay? So here with list append, I can say append the letter X to the list, and it's going to modify that list and append the value X to it, okay? If you try to do append with a tuple, it's going to say, hey, we have no attribute append there, okay? So, so these things, append, insert, pop, whatever, any of those methods that modify a list, they just don't exist for tuples, okay? If you want to change a tuple, you have to just create an entirely new tuple, okay? So here, if I want to change the first element in T to be, from 0 to say the character A or whatever, I can create a new tuple. I could take the existing tuple, take another tuple with A, append those two things together, not append, but add the two together, concatenate them, and then I can assign that back to T, okay? And now T is this tuple. But what I've done here is I've just created an entirely new tuple and I've replaced the old tuple. That's all, okay? So this is not modifying. This is just creating over here. We're creating a new thing, and then we're assigning it back to the name T that was used before, and we're just replacing it, right? So that's different from modifying something. That's just creating something new and replacing the old one. Okay, so this creates an entirely new tuple unrelated to the other one. Okay, relational operators work with tuples and other sequences, and the way it works is Python starts by comparing the first element from each sequence. If they're equal, they go to the next element and compare those, and so on. Okay, so much like you would compare, so if you are told to alphabetize the word, put this sequence and right? And if I said, hey, which one comes before the other, if you had to alphabetize these sequences, you compare the first one, and then if that's a match, you go to the second one, you go, okay, B comes before C, and so on and so forth. Similarly, we say, okay, between 0, 1, 2 and 0, 3, 4, we compare the first element, the zeros, they're the same. So we go to the next, and we go 1, 1, and 3, okay? And the 1 comes before the 3, so we're going to say the first thing is less than the second, okay? Here I've got 0, 1, 2, 2 million, and 0, 3, 4. And again, we're just comparing the first, then the second, right? And so even if I change this last letter from C to say Z, okay, it doesn't matter. It doesn't matter that this Z comes after D. That doesn't play a role. We compare A, and then the first element, then the second element. Still, the B comes before the C there. So that still applies. So the 1 still comes before the 3. It doesn't matter that this is 2 million and this is 4. It doesn't matter. So this is still going to be true. Whereas here, if the second element is 500, which is bigger than 3, then now the element on the right, okay, or the tuple on the right comes before the tuple on the left. Okay. All right. Similarly, you can take take words like ABC or ABCD, all right, and then you do a tuple comparison, and ABC comes before ABCD, and you can do kind of any of these other things. What about ABB? ABB comes before that. What about ABC versus ABB? Okay, so that will be false. Okay, so however you want to do it. A very kind of common idiom that we do is we can use a tuple for kind of switching values. So I don't know if you've ever had this problem before where you have like A is 5 and B is 1, and you want to switch these things, and now you want B to be 5 and A to be 1. You want to kind of just switch the position of these values. If you did this one line at a time, you would often have to create like a temporary placeholder. So you would take the value at A, assign it to the temporary thing, and then you would take B and replace A with it, and then you would take that temporary thing and replace B with it. Okay, and then this would successfully swap the values A and B. Okay, so A is now 1 and B is now 5. Okay, and if you didn't use the temp, and if you just tried to do B is equal to A and A is equal to B, you know, as soon as you rewrite the A, like if I didn't do this, okay, we could see that, you know, if I did A is 5 and B is 1, then I say B is equal to A and A is equal to B, we're going to see that A and B end up having the same value of 1 here, right? So you'd have to, you know, kind of set the value B to here, to the temporary value, and then, oops. All right, and so this would work, okay? But with tuples, Python can interpret and read these things, and you can swap values like this. So you can say A is 5 and B is 1, and you can say B comma A is equal to A comma B. You can assign A comma B to the values B comma A, and this will work. Python interprets this instruction all at once. Okay, rather than reading one line at a time, it's going to interpret this instruction all at once. And so this is a very kind of handy feature that we have. So we can kind of do this tuple unpacking and reassignment instantly right here. Okay. Here's a function. So sometimes functions return multiple elements. Okay, so for example, a common function is string split. Okay, so here I've got an email address, and we're going to say split at the @ sign to get kind of split it into username and domain. And when you do this, normally you would get back a list with 2 elements. Okay, element before the A @ sign and an element after the @ sign. Okay, what you can do is you can kind of capture that what this returns. If you know that you're only going to get kind of 2 elements back, you can capture it into a tuple of kind of variables. So we're going to create a tuple with variable name, variables uname and variable domain here. And so I'm going to take this address and I'm going to do split, and we do the tuple assignment here. And then so now I have the variable for username and the variable for the domain, and these things are right there, right? And so this is very kind of handy, because if you know the form in which your function is going to return multiple elements, you can kind of capture each of those elements into certain things with a tuple there. Okay, So here is there's a function that we can write ourselves, and this is going to do this is going to be a division function. This already exists in R, but we can create our own, and we can say, hey, I want to do x divided by y, and I want to get an integer component and the remainder. Okay, so we're going to say x is going to be the integer division, floor division, x / y for floor division, and the remainder will be x mod y to get the remainder, and then return the tuple consisting of integer and remainder. Okay, so if we do this, this returns the tuple. If I do 23 divided by 5, we're going to get 4 remainder 3. And so j, when if I say, hey, capture the output into j will be the tuple 4, 3. Okay, 23 divided by 5 is 4 remainder 3, right? So you can, and I think we talked about this when we talked about functions. So functions can return multiple values as a tuple, or you can also take that output and unpack it, okay? And so we could say, well, I know it always returns a tuple with integer and remainder, so I can always unpack it into, say, values a and b. Okay, and then so a is going to be 4 and b is going to be 3. Okay, there's already a function in in Python that does exactly this division. Okay, that's div mod. Okay, and it does exactly the same thing as what we wrote here. But here, this is the floor and remainder, floor division and remainder, and that's div mod. There are 2 methods that tuples have. Okay, you have dot index and you have dot count. Okay, because these are things that aren't going to modify the tuple. So dot index works kind of like exactly the way dot index works for the list, which is like it's going to return the element where it finds that thing. So if I say, hey, dot index dog, okay, it's going to tell me that dog is in the index 4 position. Okay, if I say t.count 5, it's going to go through and count how many times 5 appears. Okay, and this is count character 5. Okay, so character 5 appears once, whereas I can run this and I can do count integer 5. Integer 5 appears twice. Okay, so integer 5 and character 5 are seen as different things. Okay, index of integer 5 gives me back the index of integer 5, which is in the index 8 position. So 5, 6, dog is at 7, and this one is at index position 8. And then again, dot index, if you give it something that doesn't exist, okay, you get back an error, right? It says you get a value error. It says x is not in the tuple, so you don't get back the index position. Okay. Here are some functions that support tuples and other iterables as inputs. So you have things like length, sum, sorted, min, max. None of these functions will affect the tuple or the list or the iterable itself. So here is a tuple of some digits. Here's a list of some words. Okay, so this is a tuple and this is a list. And so you can say, hey, what is the length of some digits? So this works for tuples, this works for lists. Okay. Oh, I'm sorry, length and sum, this works for the tuple. Okay, I've got, it takes the integers, it sums them up. It tells you how many, what the length is, okay? If you try to do sum on some words here, then you get back an error. It says, I don't know how to add strings together, all right? So that makes sense, okay? You could take a tuple and you can sort it, okay, and call sorted. But again, this takes the existing tuple and then it sorts it, but it doesn't affect the original tuple, right? So this just gives you back a sorted version of those elements. And also note that when you call sorted on a tuple, it returns a list, okay? It returns a list. So it doesn't return a tuple in sorted order, it returns a list of the elements in sorted order, right? Okay. Whereas, again, the original tuple itself is unchanged. Same thing with the the list of words, you can sort them in alphabetical order, and that works just fine. The minimum, the maximum, those things work exactly as you would expect. If you have a list or tuple where elements are mixed together, you have strings and integers together, then it says, I don't know how to sort this, okay? You can also, these functions also work with dictionaries. So I've got dictionary where the keys are numbers, and I've got dictionary where the keys are letters, alphabet characters. So you could say, hey, how many elements? What is the length of this dictionary? Okay, and basically, how many keys do you have in the dictionary? You got 3 keys in dictionary. Okay, can you take this dictionary and sort them? So you're like, well, first of all, dictionaries aren't sorted. So what we're saying is take the keys and sort the keys. Okay, so the keys in sorted order would be 1, 2, and 3 for this dictionary. Okay, for the alphabet, the keys of the alphabet in sorted order are A, B, C. Okay, and then if you say, give me the max, okay, max of a dictionary is going to be kind of your max key element, max key. So, so here we're just, when you basically call any of these functions, any of these length sort, sum, sorted, min, max. Well, actually, I don't, sum on a dictionary, I think is going to try to sum the keys. Let me see. This is something we don't typically do, but I think, so if I do sum dictionary numbers, I think it's going to, yeah, sum the keys. So basically, it's just operating on the keys, and it works these things, okay? But so it feels a little bit strange, okay? But that's what you have. Okay, these things work for any of these kind of iterables, lists, tuples, and strings, and I think the strings one is probably the ones that is a little, perhaps the most surprising of any of these. But then if you just reframe the way you think of strings as iterables, much like a list or a tuple, but the elements are just characters, then all of these things kind of make sense because they all work in the same way. So multiplication just takes the thing and duplicates it. Addition takes the things and just appends them together. And the way these things work is very similar. So here I've got 2 lists, L1, which has the elements A, B, C, and L2, which has the elements D, E, and F. And so if I do L1 times 2, I get what? A, B, C, A, B, C, okay? If I say L1 plus L2, it appends those 2 together, and I get A, B, C, D, E, F, okay? Here are tuples, tuple with the letters A, B, C, and tuple 2. T2 is a tuple with the letters D, E, F. And again, this works exactly the same way. T1 times 2, I'm going to get A, B, C, A, B, C, but as a tuple. T1 plus T2, I get a new tuple with the elements A, B, C, D, E, F. Okay. If you try to add a list and a tuple together, Python gets mad at you. Okay. It says you can only concatenate a list to a list, not a tuple. Okay. I mean, this is a very handy error message, right? And I want you guys to start reading through the error messages. And rather than just going, oh, I got an error message, I don't know what to do, read through the error message. And a lot of times it will tell you like, oh, this is exactly what's going on. Wrong. You're trying to add these 2 things together and you can't do that, okay? What you can do is you can take an existing tuple and you can convert it to a list and then you can add it, all right? So you do that. And then again, all of these things, I didn't do this, but if you do ABC is string 1 and string 2 is DEF, you know, exactly the same kind of thing happens, right? So if I do string 1 times 2, we're going to get string 1 times 2, okay? Then we're going to get ABC, ABC. And if I do string 1 plus string 2, then you get ABC, DEF. So those kind of the same kind of addition and multiplication, they work the same way with strings as well. Sometimes a function will accept arguments, but it will be variable number of arguments. So it can accept like 1 argument or 10 arguments or things like that. And anytime you see a parameter name where a star that has a star, it's going to gather multiple arguments into a tuple. Okay, and the convention is when you're going to do something like that, you're going to call it star args. But technically, you could call it star anything you want, but you'll do it star args. Okay, so this is kind of stupid, but we're going to just create a function called print all, and this we'll call print all args. And if I try to run print all here, and I try to give it 4 elements in here, because the way this function is written, it's expecting only 1 argument. Okay. And so this is going to fail, right? It says you gave me 4 arguments here, and this function is only going to accept 1. Okay, but here I can say if I just call, when I define my function and I call the argument star args, then Python understands that it can be fed multiple arguments, not just 1, but perhaps 4, 10, 15, however many you want. And it's going to take multiple arguments and just gather them together into a single tuple. So now star args, the elements get gathered into a tuple, and when I say print all the args, star args, these 4 things get gathered into a tuple, and it just prints out the tuple with 1, 3, 5, and high in it. Okay. If you just give it a single element here, then it creates a tuple out of it. Okay. And we get a tuple of length 1. All right, and so for example, here I can create a function called print lines star args, and then now that we know that this is going to gather them into a tuple, now I can iterate over the tuple with a for loop. So I could say for each element in that tuple that we've gathered, go through and capitalize whatever that element is and print that out. Okay, so here I got hi, I love you, goodbye. Those 3 things are going to get gathered into a tuple, and it's going to capitalize. Capitalize only capitalizes the first element. It's not title case. So we get capital hi, capital I for I love you, and then capital G for goodbye. Okay. If you just give it 1 argument here, okay, it'll gather it into a tuple, and it will capitalize. It'll try to capitalize the string 1 here, and it just says 1, and we get that. All right, second answer today is the letter A. A is your second view quiz answer. Okay, kind of the complementary function to gather is scatter. So if you have a sequence of values and you want to kind of pass it to a function as multiple arguments, you use the star operator, right? So for example, here our function myDivide returns a tuple with 2 things, right? So here I get myDivide, and we get a tuple with the values 4, 3, right? 23 divided by 5 is 4 remainder 3, okay? Here, what if, no, I want to do 23 comma 5, sorry. Okay, so 23 divided by 5 is going to be 4 comma 3. So my tuple here is 23 comma 5. Now, what if I called myDivide on t here, okay? Right now, this is going to result in an error, okay? Because it's saying this myDivide function, we need an argument for x and an argument for y, okay? And what I've done is when I call this function, I'm just saying I have an argument, I'm giving you 1 argument. It's a tuple, okay? But it doesn't even try to interpret that yet. First, it tries to say, okay, I need 2 things. I need an argument for x and an argument for y. And right now I only give it one thing, the t. And so it says I'm missing a positional argument for y. I don't have anything for y. Okay. Now if I said 2, 3 or something, then it's going to run into a different problem because now it will have a value for x and a value for y, but now the value for x has 2 elements in it, and then it's going to get confused. Now we're going to get a different element here, right? It's going to say, wait a second, x is a tuple, and now you're trying to divide by y, so that's a different thing. But here, the very first line, if I just say, hey, I have 2 arguments in tuple, I've got 2 values in t, the 23 and the 5, and I want to do that, it just says, hey, I need something for x, I need something for y, and you've only given me one thing, okay? Whereas you can take elements in a tuple and then what we call scatter them. So here, t is this tuple with values 23 and 5, and here you call star t, and this takes the elements in t and it scatters them across the 2 values, and it says, oh, you've got two values in here, 23 and 5, and we'll scatter them. 23 goes to x, 5 goes to y, and that works this way. Okay, so multiple elements gathered into one thing with args. You call star args into the definition of the function. Whereas if you have a function that accepts multiple arguments and you have a tuple that contains those multiple values, you call the function with star on the tuple, and it will scatter them. Okay, other things we can do. All right, so we have a function zip, and we've talked about zip before when creating a dictionary. And what zip does is it takes these multiple iterables and it kind of interleaves them. It's like if I gave you a stack of papers and I said, I want you to collate these, right? I want you to take, the first page from here and the first page, match it up with the first page, and then take the second page and the second page, and so on and so forth. And that's what zipping does. And so here I've got basically 3 different iterables. I have a string with letters ABC. Each of these things have length 3. So S is a string ABC. T is going to be a tuple with 0, 1, 2. And U is another tuple with strings apple, banana, cantaloupe. Okay? I was trying to think of fruits with C. Coconut. Okay. All right. And so if I zip S and T together, we're going to, this just creates a zip element. Again, Python is lazy, and it's just going to say, all right, you want me to collate these things? I'll get to it when you ask, when I need to. And it creates a zip thing. But you can say, hey, you know what? I really want you to do this, okay? So we're going to zip, and you can zip multiple things together. So you can zip S, T, and U all together. And it's just, again, it's like I gave you a stack of 3 things, and I say, hey, collate all of these things together. So you're going to match up the A, the 0, and the apple. Then it's going to match up the B, the 1, and the banana, and the C, and the 2, and the cantaloupe. And we're going to just kind of print this, okay? So for each of these things, it collates them into basically a tuple with those 3 elements. So we're going to get a tuple with A0 apple, tuple with B1 banana, and a tuple with C2 and cantaloupe. So this is how zip works together, okay? And again, zip is an iterator, okay? And what that means is basically it's a set of instructions that Python only, again, it's lazy, so it only is going to evaluate what these things are, and it will say, okay, your first thing is A0 apple, but it's only going to give it to you when you ask for it, right? So here, when we're zipping this thing, it's printing them out because we specifically said, for everything in there, I want you to do the work, and I want you to print out what you're getting. So Python goes and it prints all of these things out, okay? They are kind of, the iterators are like iterables, like a list, okay? However, because the way Python evaluates things is lazy, it doesn't know, like with a list you can say, hey, I want the 5th thing in the list. I want the 80th thing in the list. And because the iterator is lazy, Python doesn't know what the 80th thing is until it gets to that 80th thing. So you can't, so with a list, you can say, hey, I want the 80th element. But with an iterator, which is just the instructions that says, hey, start, follow these instructions and do it, and there might be 100 things in the thing, it's not going to know it until it gets to it. But what you can do is you can say, hey, zip everything together, put everything together into a list, and then we can talk, right? So here I can say zip S and T together. So it's going to zip the ABC and the 0, 1, 2 together. And then we say, hey, take that and throw it into a list. And so now we will get a list, and we'll get all of them. We'll get a list of the tuples there. Okay. If you zip things, okay, with different lengths, and I don't know why I picked these examples, but if I did like A, B, C, D, E, okay, and over here I just did A, B, C, okay, and I zip these two together, it's just going to return the shorter one. So the D and E over here just gets thrown out, okay? They just get lost, okay, if you try to zip. So it's like if I gave you 2 stacks of paper and one was shorter than the other, you collate, and I say, hey, collate these together. You collate what you can, and then if one of them is longer than the other, you just throw away the rest, okay? It doesn't complain. It doesn't give you an error and say, hey, you gave something of the different length. It just says that. I had these left over and I just throw them out. Okay, that's what we have. So if you do have a list of tuples or an iterable of tuples, so here you can unpack them as you iterate through them. So here I got A0 and B1 and C2. We can go through this, iterate through them, and unpack them. And I can say, hey, print out the number, print out the letter, whatever we want. Okay. We can say number is this, and letter is this. Okay. And it will go through, and it will, and it does exactly what you want it to do, right? So unpacks them, 0A, B1 and C2, and it does these things, just iterates through them, okay? So T is this list of tuples. If you just say item in T, okay, and you say print the item itself will be the tuple, okay? And then you can take that tuple and then you can kind of subset and say, I want item index position 1 or whatever, okay? And you can do that. So you can either unpack it directly in the for instructions if you knew your tuples are at length 2, okay? But if you give it something, right, like here is a tuple, like this is gonna break the code, okay? Because I've got a tuple of length 2, I have a tuple of length 3 here, okay? And then every time I run through it, it's going to unpack them into tuples of length 2, and it's going to output this stuff here, okay? Now, Python, again, it just reads left to right, top to bottom. So it will work for the first 2 elements. It'll successfully unpack the A and the B, the A and the 0, the B and the 1, and it's only until it gets to the 3rd element here, and it says, uh-oh, I can't unpack this, okay? So we will get the 0A, the 1, the B, and then when it gets to the 3rd one, this is where it says, uh-oh, now I've crashed, okay? Now I've crashed. Okay, so here I'm zipping S, T, and U, the string, I don't know, where did it go? Okay, and then so now we can unpack this and say the letter is this, and the number is this, and the fruit is this, and oh, I forgot. I got to reassign S, T, and U. Okay, so let's copy this. C. So you're gonna have to do a little bit of modifying here. Paste that in there. Okay, so here's S, T, and U, and then we'll zip those together, and it works. ABC 0, 1, 2, so on and so forth. Okay. All right. Iterable 1, 2, 3, 4. I've got ABCD, range 5, apple, banana, coconut, date, elderberry. Oh yeah, that was the tricky one. Is there another fruit with an E? Okay. And then 2, 3, 5, 7, 11. I think those are prime numbers. All right. You want to zip all of them together? No problem. Okay, what is X? X is just a zip. It's just instructions. It says, all right, I'll collate these when I get to them. You say, I want you to do it now. Okay, now you call list on X. And then it says, fine, I've done it. Okay, I've done it. And then if you ask, what is X now? It's still that. Okay. If you want, you can run, here's a little bit of code that will kind of traverse two iterables and see if like the elements are the same. So we're going to call this has match. And here we're going to do T1 and T2. We're going to zip these two together and we're going to unpack them into X and Y. And then we'll just check to see if X is equal to Y as we iterate through T1 and T2. Okay. And if there is a match, it'll return true. And once it returns true, once a function hits return, it stops running. Okay? So this for loop, there might be like 1,000 things to evaluate, but once it evaluates, as it's iterating through it, once it hits the return, that function has returned a value, the function sees its life as complete, and then it quits. Okay? Whereas, at the very end, if the function goes through this entire for loop without encountering this conditional statement to return true, then the function will return false. Okay, so here we're going to compare ABC with DEF. There's going to be no match, so this will return false. We're going to compare ABC with DEC. Then this will return true because it will find the C and then match there. And we got that. Here I've got ABCD. Does it ever match DCBA? So it compares the A and the D. It compares the B and the C and the B and the D and the A. It has no match because there's no time where the two things are aligned to match up. Okay. Okay. There's one more function, and this is called enumerate. All right. And enumerate is like zip, except you give it just one iterable, and then it's always zipping basically with a range object. Okay, so basically it's like so morning is what, 6 characters long? No, 7 characters long. So it's like taking a range 7 object and zipping it with morning. Okay, and then you get an enumerate, and you get an enumerate object. Again, Python is lazy, and it's only going to like collate these two together when it has to. Okay, but basically it's going to match morning with a 0, O with a 1, R with a 2, and so on and so forth. So you're basically getting a zip object, okay, but you're zipping a range 7 or whatever length the iterable is. So in our case, morning is a string which is an iterable of length 7, and you're zipping a range 7 object with the string morning here. Okay, so if I say, hey, here's a list ABCD, and I say enumerate that. Okay, and then I want everything. Okay, we're going to get a list of tuples, and it's going to be 0A, 1B, 2C, so on and so forth. Okay. If I did it manually myself, I said, hey, here's a range 4 object, and zip the range 4 object with ABCD and make it into a list, we're going to get back the same thing. Okay. So enumerate is like a shorthand for zipping with a range object. Okay. And it's just like, this was like such a common action where you're just like, I need to kind of just like, just need to list everything off. So I get 0, 1, 2, 3 or whatever. They said, hey, you know what, let's just make a function called enumerate. And this is going to basically be like a shorthand for this because it's pretty common thing. Okay. So here's a dictionary. Okay. And here you have the items. The items in a dictionary are kind of like tuples, and you can unpack them as tuples and so on and so forth. You can take you could take a thing, enumerate it, and then make a dictionary out of it, okay? And then basically the keys become the, 0, 1, 2, 3, or whatever become the keys, and so on and so forth, okay? Here I've got, all right, let me just kind of do all of this. Okay, I'm going to just skip to this part down here. Tuples as dictionary keys, because this is the important thing. So remember, with dictionaries, the keys have to be immutable, okay? They have to be hashable. So you cannot have a list as a key in a dictionary, okay? But tuples are immutable, so they can serve as dictionary keys. Now, why would you ever want a dictionary key? Why would you ever want a tuple to be a dictionary key? So an example is if you want to be able to look something up in a dictionary, but the thing you want to look up might have there might be 2 elements or multiple elements, okay? So for example, a set of coordinates, or I don't know, just imagine a multi-layer index or something. So for example, you could just say I want to look up information on in a dictionary, you can look up country name or something, okay? But you might also have historical records. So you might want to be I want to look up in 1943, country name, or a 1987 country name, or something like that. And so you have kind of 2 things to look up. And in that case, a dictionary where you're using a tuple to look up the thing might make sense, okay? Another example is you could have a function. And you might have coordinates, x and y, to look up, right? Now, this is a dumb function, and we could just plug in x and plug in y and get a result. But imagine this function, whatever it is this really complicated thing. It could be this huge Taylor series that we have to, it takes a long time to compute each of these things out. So what might be useful is to kind of create a record book and say, hey, we figured out the solution to, if you plug in 15 and 75, we figured out that solution. We don't have to compute it again, right? So you can kind of create a dictionary of solutions that have been computed. And then if the solution hasn't been computed, then you compute it out, okay? So here, I'm going to create a function for x and y, okay? We're going to take the arguments x and y as a tuple. If that tuple exists in the known dictionary, then we'll say that value already exists, and then we'll just return that known value, okay? But if it doesn't, then we'll calculate it, and then we'll add that record to the known dictionary. So what I'm going to start off with, okay, 0, 0 already exists in my dictionary, all right? And then so we'll return that. Right now, my dictionary only has 1 known value. Here we're going to calculate 1, 2. That has to be calculated. So now my known dictionary now has 2 values in it, 0, 0, and 1, 2. And then if I call 1, 2 again, it says, oh, you know what? That one already exists in the dictionary, and it returns that value, and we get that back, okay? All right, so that's an example of where you could use tuples as dictionary keys. Okay, we will end our lecture here, and then